Okay, so that's the volatile implementation. Let's go take a look at one that's a little bit more modern. So here's one that uses an enum. So you can do this with Java. I think this is certainly supported in recent versions of Java. I'm not sure whether it was always done this way, but it certainly works in recent versions as well. And in this case, we define a singleton called singleton E, which is an enum. It implements the singleton interface because, believe it or not, you can have enums that implement an interface, as we'll see. And then here is the one and only instance of this enum, which we call instance. So that is actually the enumerated literal, or the enumeral, as we sometimes say. Now, something you may not have realized, in Java, you can define a non-static field in an enum, which we do. So now we have mField. And we can also, believe it or not, define a constructor for an enum. And in this case, once again, we print out the fact that we're in the singleton enum constructor, and keep an eye on that because we want to make sure this only gets run one time, which it will. And then down here, we define the get field and set field, setter and getter methods. And you can see that all they do is just return the field or update the old field and return or update the field and return the old value. So that's the implementation of that. Very, very simple. There's hardly anything going on here at all. And so it's kind of interesting. If you want to read more about how to do this particular approach, then take a look at why enum singleton are better in Java. I'm not sure why it is not why enum singleton is better in Java, but whatever. That's the link, and that's the information that we'll talk more about this approach. Pretty cool because there's no double-check locking. There's really not much of anything that we have to do to make this complicated at all. So that's the singleton that's implemented as an enum. Let's now take a look at a singleton that's implemented using the so-called holder idiom. And this is something that you can read about here at this link. There's also a link from, I believe there's a link from the double-check locking pattern Wikipedia entry that talks about this. I first saw this put forward by a professor at the time at the University of Maryland named Bill Pugh. I'm not sure if he's still at Maryland, but he did a lot of work with Java and concurrency and was a smart guy and was very interested in the whole double-check locking pattern issue, and he stirred up a lot of controversy. Let's just put it that way. So here's the way this works. So what we're going to do is we're going to have singleton H that implements singleton, like singleton E did and singleton V. As before, we're going to define a non-static field. Of course, we could have more than one field. We're also going to define a singleton H constructor, which will indicate that we're constructing this object. And again, keep an eye on this when we run the program. We'd like this to only occur once. We only want one call to these things. And then down here, we've got the get field and set field methods, which do the same as they've done in the other implementations. But now things get a little different. So check this out. We have this static nested class called singleton holder. And this is the holder idiom we were just talking about. And the way it's going to work is we're going to have a private static final instance of singleton H called, for lack of a better term, instance. And you can see here that we make a new singleton H instance. And this is going to hold the singleton. And the way this works is this field here, this instance field, will be initialized when the singleton holder class is loaded. So when this class comes into existence, then this object is created, and it's all done in a thread-safe way. So we don't have to worry about double-check locking or volatile and so on. And then all we do here for the instance method is we simply return the instance field, which would have been initialized already here because of the holder that does this. So this is pretty nice. The downside is that this doesn't implement one of the characteristics of the singleton pattern, namely the ability to create the object only when it's accessed. So this will make it when it's loaded, but not when it's accessed. And so the way that singleton works normally is that if you don't access it, it's never created. So if you had a very large object that was going to be created here, that this one isn't very large, it just has one one non-static field in it. But if we had something with a lot more state, then that would always be created. Whereas the other implementations that we saw, in particular, the one that uses the volatile implementation, those objects, those singletons, are only created on demand. So that's the holder idiom version.